here are the big ideas for section 2.1. So the first topic is percentile. Percentile is the percent of values that are less than or equal to an individual value. So if we had a list of numbers, and let's say these were quiz scores. Mr. Nansky got a 7 on the quiz. So there was 4 out of 7 that were less than or equal to Mr. Nansky's score. Which is about the 57th percentile. So as percentiles go, the higher percentile, if it was test scores that we were talking about, the better you did on the test. You've probably seen these before with ACT scores. Cumulative relative frequency graph. So this is going to be graphing your data values will go on the x-axis, the cumulative relative frequency will go on the y-axis. So a couple things about this. As you go, it's always got to start at 0. And then it'll go up, maybe go something like that. Always has to end at 1. So as we go up, it tells us what percent of the data fall below that point. So let's say this is maybe a 5. If we go straight up and then straight over, the percentile for the value of 5 would be just over 50%, maybe like 55% would be the percentile for that data point. If, let's say, this value was an 8, going all the way up, all the way over, 100% of the data follow that. So cumulative relative frequency graphs will tell you percentiles using that method. A z-score. A z-score is given by this formula. Value minus mean over standard deviation. Now this will tell you how many standard deviations above or below the mean you are. So z tells you the number of standard deviations you are, combining my words, you are above or below the mean. So if your value is less than the mean, it's going to be a negative number by plugging this in, because a value lower than the mean is going to get you negative. If your value is above the mean, you're going to get a positive number. So you take your data value that you want to look at, subtract the mean, and divide by the standard deviation to get a z-score. And that will tell you how far above or below the mean that data point is. If you have a set of data, so let's just go 1, 2, 3, that's our set of data. If you add a number to each value, so let's say we add 2. So our new data set would be 3, 4, 5. We added 2 to the original data set. We're concerned with 3 things: the shape, the center, and the spread. The shape is going to remain the same if we were to graph it. The center, if you notice, 2 would be the mean or the median that went up by whatever value we added. If A is a negative number, you could also go down. So it's going to go down by whatever value you add or subtract to the data set. Now the spread, originally the range 3 minus 1 is 2. If we look at the range here, it's still 5 to 3. So the spread also remains the same. So if you take an original data set, you add a number to it, shape stays the same, centers will go up or down by whatever the value is, and the spread will remain the same. But if you take a data set and you multiply or divide, let's say we multiply by, let's go with 3. So then we'll have 3, 6, and 9 as our new data set. The general shape is going to remain the same. So whether you add or multiply, the general shape remains the same. The center was 2, went to 6. It just changed by whatever value we multiplied it by. So you just multiply or divide by the value to figure out the new center. And the spread, now if you look at the range, it was 2, and now it's 6. So the spread also increases, gets multiplied or divided by the value. Now with a small data set like this, probably don't need those shortcuts, but if you have a larger data set where you're adding numbers or multiplying numbers, you can talk about the center of the new data set much easier by just using these rules.